So this is 5-6 day 2. We are going to talk about solving nonlinear systems of equations. So let's think for a minute what we've had so far. We've looked at two equations, linear equations. They meet up at a point or they don't. Very simple, straightforward in 5-6 day 1. But let's think about the difference here. In problem number 1, we have technically that first equation is a parabola when one is squared and one is not. It's a parabola. The second equation is a line. So if we have a parabola and we can cross it with a line in 2 spots, we can cross it exactly 1 spot, or maybe our line never hits the parabola at all. So you could possibly get one answer. You could get 2 answers, or no answer at all. So that's why we need to be very careful when we're doing these, and especially make sure that you check your work. Now let's take a look at problem number 1. When I do problems like this, what I like to do is I like to take my linear equation and I like to solve it for what I think of as the simplest variable in both. So I'm going to rewrite this as y equals x plus 4. Now that's what I'm going to substitute into the upper equation, okay? So I'm going to get x squared minus that quantity equals -2. So you'll notice that my equations are now only containing x's. So let's distribute that negative. And you might recognize that as a quadratic. Now, to solve a quadratic, that -2 needs to be moved to the other side. So let's add 2 to both sides. And then let's factor it. So we get x minus 2 and x plus 1. So we get solutions of 2 or -1. Now, remember, this is an ordered pair. So what's great is we've solved this for y. So let's stick our x of 2 back in, and we get 6. Let's stick our x of -1 back in, and we get 3. So we should see that the line crosses the parabola in 2 spots. Now here's where an application like Desmos is very, very helpful. So let's go ahead and let's put in our first equation. And then let's put in our second equation. And we see, I'm sorry, my 2 equations got a little messed up here. Let's see if that helps. There we go. We can see that they do indeed cross each other at 2, 6 and -1, 3. So that's great. And so try the algebra yourself and then make sure to check it in something like Desmos. Okay. Now, 2 is a similar problem. We've got a parabola and a line. Same thing for 3. Now, 4, technically that is a circle with radius 1 and a parabola. So it could hit it twice. It could hit it once. Or it could maybe not hit it at all if it's too low or too high. So I'm going to have you try 2, 3, and 4. And then the last ones I want to do are 5 and 6. So let's talk about 5. Now that is a circle and a parabola. Now how do I know that? Well, x squared plus y squared equals a number. That's a circle. When one of our variables doesn't have a power on it, it's the first power, and the other is a second, that is a parabola. Okay. So let's see, where does a circle and parabola hit each other? So now here, there's a few different ways that we can approach it. I'm going to use elimination because I see this. If I eliminate the x squareds, I will only have y's in the problem. But to do that, I need to multiply everything on top here by negative 2. So I'm going to kind of spread it out a little bit. I'm going to get negative 2x squared plus no y's. I'll show you that in a minute why I put that there. Minus 2y squared equals negative 2. And then 2x squared plus 2y plus this one doesn't have any y squareds. And you don't really have to put these, but it's just helpful so that you try, to add the correct like terms together. So I have eliminated my x's from the problem. So that's one technique you could use. You could have also solved this for y, substituted it in, but you do get some pretty high powers, and it can be a little funky that way. So if we do it my way here, we get that 2y equals, oh no, I'm sorry, no equals yet, minus 2y squared equals 0. And since it's equal to 0, we can immediately try to solve it. I can take out a 2y from both, leaving me 1 minus y. I get 2y equals 0, and 1 minus y equals 0. So y is at 0, and y is at 1. So that's good. Those are nice points. And let's go ahead and plug that in somewhere. The easiest equation containing both x's and y's, I think, is probably this top one. So we get x squared plus 0 squared equals 1. So x squared equals 1. So x is plus or minus 1. Remember when you're square rooting. And then if we get x squared plus 1 equals 1, then we get x squared equals 0. So x equals 0. So technically, when I plugged in 0, I got 1 and I got negative 1. When I plugged in 1, and I'm sorry, I switched my x's and y's. When I plugged in 0 for y, I got 1 and negative 1. When I plugged in 1 for y, I got 0. So I'm thinking that this circle, the parabola, fit in it so perfectly that it hit it 3 times. So how can we check? Well, that's where Desmos comes in. Let's go ahead and put these in Desmos. So we get x squared plus y squared equals 1. That should be a circle at the center, 0, 0, radius 1. And then 2x squared plus 2y equals 2. Oh, it's upside down, but yeah, look at how perfectly it did that. It hit it exactly in 3 spots. That's kind of a neat one. So don't forget, when you inflict the square root, you put a plus or minus. Plus or minus 0 is still 0, but plus or minus 1 does give you 2 different points. So that's a cool one. And now let's do number 6. Now, in the last problem, I eliminated the x squared from my problem, which is totally okay to do that. We could use substitution on this problem, but I think elimination to eliminate these x squareds is probably our best bet. So let's multiply this top equation by positive 2. So we'll have a positive 2x squared and a negative 2x squared. So we've got 2x squared plus 2y squared equals 12. And then negative 2x squared plus y equals 7. And so then these disappear. We get 2y squared plus y equals 14. That is not 14. How about 19? And then we get 2y squared plus y plus 19 equals 0. Now that's not a factorable quantity, so the only way to find the zeros is to use the quadratic formula. So we get negative b plus or minus the square root of b squared minus 4 times a times c is negative 4 times 2 times 19, which is negative 152, all over 2a's or 4. Now, this right here tells me that I am going to get an I. Remember, if you get a negative under a radical, we get negative 1 plus or minus the square root of negative 151. That tells me there's an I there. That tells me that there is no real number where these meet. So that is a no solution. So what does that mean? Well, that means our circle and our parabola are just, I think it's an upward parabola, but our circle and our parabola are maybe sitting next to each other and they don't meet up anywhere. So let's check that. So let's do these ones to just verify that our math is coming out what we think. Remember, our algebraic manipulations and our geometry should always line up. If they don't, one of them is wrong. And I was right. My parabola is up too high and it doesn't cross over my circle. So that is systems of nonlinear equations. Please, at this time, before the end of class, it is your job to finish 2, 3, and 4. Give those a shot and then turn those in by the end of class.